we had the problem C times 1, 7, negative 9 added to the row 4, 2, 6 gives us a row with 0 here and asterisks here. Now an asterisk just stands for an unknown number, and they don't have to stand for the same number. So what do we do here? We have to find the value of C so that when you add C times this row to this row, you get a 0 here. And whatever you get here just follows from whatever the value of C is that gives you 0. Well, what do we multiply by 1 so that when added to 4, it gives us 0? The answer is pretty clearly C equals negative 4. And we see that the negative 4 multiplied by this row added to this row. Well, the negative 4 multiplied by this row gives us this, giving us a negative 4 here, which is going to be added to this 4 when we add the two rows, giving us 0. And what goes along with that is just what we get. So there is our sum. Now there are ways we could actually set this up with equations and so forth, but we'll just do it intuitively right now. Okay. Now here's another one. What do we multiply 6, 5, negative 1 by in order to get a 1 here? And then two numbers here that follow from whatever it is that makes this 1. Okay, well, clearly then, what do we multiply by 6 to get 1? It should be clear that we multiply by 1/6. So 1/6 times this, let's just test it out. That equals 1/6 to 6 is 6 over 6. 1/6 to 5 is 5 over 6. 1/6 of negative 1 is negative 1/6. 6 over 6 reduces to 1. So, just as we expected, if we multiply this row by 1/6, we get a 1 here. It's as simple as it might seem. Okay, another topic is vectors. So I just gave a short introduction to vectors, a couple of short examples. A vector can be represented in an XY plane or any plane by an arrow. And that arrow has some length. Now the vector I've drawn here has a length of 6 and an angle. The angle is measured counterclockwise from the positive x-axis. So this vector, magnitude 6, has angle 120 degrees. It's supposed to have angle 120 degrees. When I look at it from this angle, that looks almost plausible. It's a little too far this way. When I look at it straight ahead, it looks more like 130 degrees, or closer to 130 than 120. You can measure it and see how accurate my estimate is, but you get the idea. Okay. Now, if I have a vector, the vector 2, 3, that's indicated in one of many ways. There are many ways to do this. One way is with a pair of parentheses and an arrow over the top. Another way, if you're typing, is to just write it in boldface. And there are other notations that we're not going to worry about. We just want to get the idea. Okay, I mean, we are going to worry about it. We're just not going to worry about it right at this moment. We're going to worry about it very soon. Vector 2, 3. What does that mean? Well, you can picture that as a vector from the origin to the point 2, 3, where we go 2 units in the x, 3 units in the y. So here's the point. Two, 3. The vector starts here. This is called the initial point. That's going to be in the handouts that you'll work on for next time. And the terminal point is the point where the head of the arrow is going to be, okay? You have an arrow from the initial point to the terminal point, head of the arrow, point of the arrow on the terminal point. I will mention, didn't draw it or anything, but I did mention it. This vector can actually go any place in the plane. It's not confined to having its initial point as the origin. It doesn't change its length when you move it around, and it doesn't change its direction when you move it around. So it stays like this. I could move it over here, and you could think of the arrow as starting at this point and ending at this point. And you can think of that as taking this point and displacing it to this point. Something you kind of want to think about. We'll talk more about that. What's the length of this vector? Well, the Pythagorean theorem gives you the length. This is clearly a right triangle. So the length is the square root of 2 squared plus 3 squared, which is the square root of 13. The angle, know your trigonometry, the angle is the arctangent of 3/2. And there's a little more to the angle and the length, but you get the idea that if we know the coordinates of the vector, you think of this 2 as being a displacement 2 units in the x direction, 3 as being a displacement 3 units in the y direction. Anytime you do that, from where you start to where you end, the distance is square root of 13, and a line from the starting point to the end point will be the arctangent, will be an angle, arctangent of 3/2 relative to the positive x direction.